The Germans modified their night fighters, bomber interception and attack tactics, and fighter armaments throughout the war. In 1944, German night fighter pilots were captured and during their interrogations provided the RAF valuable night bomber interception and attack information. The intent of this video is to review German night fighter interception equipment, bomber attack tactics, and recommendations the POWs provided to RAF bomber crews to avoid attack. This is an AI-free zone video. This chart from a 1945 RAF Bomber Survey document outlines the strength of the German Air Force deployed in the Western Front by model type. Single-engine night fighters, like the Me-109 or the FW-190, are represented by this area sliver, where the area goes to zero in July 1944. Twin-engine night fighters, like the Ju-88 or Me-110s and others, are represented by this larger area. This video will focus on the late-war twin-engine night fighters. The principal function of the night bomber is to deliver the maximum bomb load and carry negligible armaments from a 1945 Armaments in the Air War USSBS document. They rely on the cover of darkness and evasive action if under attack. The Lancasters were generally armed with 8 .303 rifle caliber size machine guns, 2 in the nose, 2 in the top turret, and 4 in the tail. Some included an undergun periscope turret, most did not. The night fighters' goals in order of priority are listed on this page from a November 1944 Air Intelligence Weekly Summary document. Force the bomber to jettison its bombs prior to reaching the target. Force an inaccurate bomb run or target diversion. Shoot down the bomber. The fighters need to find and attack the bombers prior to reaching the target. After a German night bomber interceptor takes off, he is vectored to a beacon by the Control Airfield Office. He will orbit at a specific height and awaits further instructions on the bomber's location and course. He will then be directed towards the bomber stream for interception. Unlike day fighters, each night fighter acts independently. They do not fly in formation or coordinate their attacks. The night fighters were more or less on their own to use the plane's electronic devices to track, approach, and attack. At the end of 1943, 3 new electronic systems were available to track bombers at night, as discussed in this 1967 Ju-88 Night Fighter booklet. This included the FUG-220 Lichtenstein or SN2 radar system, the FUG-227 Flensburg radar detector, and the FUG-350 Naxos radar detector. The FUG-220 Lichtenstein radar system is modeled after the older FUG-202. This page from a 1945 War Department manual on German radar outlines characteristics of the older FUG-202 aircraft radar. The unit indicator is here and the antenna array is here. These were mounted on Ju-88s, Me-110s, and Do-217s. The return scope provides information on the bomber's range, azimuth, and elevation relative to the fighter, as seen in this image. The range of the system is 5 miles, but in practice only 2 miles can be expected. The system weight equates to 110 pounds. These radar systems and antenna increase the fighter's drag, reducing its speed by 15 miles per hour, as discussed on this page from a 1946 Air Material Command document on German electronic developments. The FUG-202 radar system was rendered obsolete by RAF countermeasures like dropping aluminum foil strips or window. By the fall of 1943, it was replaced by the FUG-220 or SN2 radar system. The FUG-220 radar was not as susceptible to window. Its effective range was between 4 miles and 400 yards. Once the fighter came within 400 yards of the bomber, they needed to rely on visual tracking, which could be an issue on a dark night. Some fighters carried the older BC or C1 sets to plug the 400 yards minimum range gap. Ultimately, the 220 sets were upgraded to allow for a closer minimum distance. The larger antennas for the long-range SN2 radar set, whereas the small antennas for the BC or C1 radar set. In practice, the fighter will approach the bomber using the SN2 radar system until within about 600 to 700 meters, then switch over to the short-range radar, closing in on the bomber to a distance of 150 meters or until visual contact of the bomber. The FUG-227 Flensburg system was designed for the fighter to home in on the Lancasters' tail warning radar. Once the RAF was aware of this vulnerability, tail warning systems were removed from the bombers. This image shows the location of the Lancasters' Monica tail warning radar antenna. The location of the Flensburg radar homing antenna on a Ju-88 night fighter. The third electronic system night fighters used to track bombers was Naxos. This system allowed fighters to home in on the Lancaster Pathfinder's H-2S radar transmissions. This image shows an RAF Lancaster Pathfinder fitted with the H-2S radar system, the radar fairing dome, the radar disc. This image shows both the SN2 radar antenna and the Naxos antenna fitted to this Ju-88 night fighter. The Naxos aerial mounted on an Me-109 fighter, the aerial with the fairing removed. The motor rotates the aerial at a rotational speed of 1,000 RPM. The Naxos system was designed to home in on H-2S radar and then later upgraded to detect the higher fidelity H-2X radar. The S in H-2S is S-band at a radar signal wavelength of 10 centimeters, and the X in H-2X is the X-band radar at a wavelength of 3 centimeters. By the end of January 1944, German twin-engine night fighters were equipped with both Naxos homing systems and SN2 tracking radar. The range of the Naxos depends on the height differential from the H-2S transmitting bomber above the fighter. At a height differential of 1,000 meters, the range is 50 kilometers. At a 2,000-meter height differential, the range is 100 kilometers. The fighters are vectored towards the bomber stream well below their known altitude. They stay outside the bomber's radar cone, otherwise they may be picked up by the bomber's radar operator. The fighter must be below the bomber to receive the H-2S transmission. This image shows a naval Naxos aerial mounted on a German U-boat. These provide a warning to the submarine that they're being tracked by aircraft radar. German POWs described how they use Naxos to track night-flying bombers on this page. Multiple radar contact indications may be shown on the Naxos screen. The system can isolate the nearest signal. The screen dot trace will form a circle if directly below the bomber. A skilled pilot and operator can get close enough for visual identification of the bomber. All other POWs, however, indicate Naxos is used for long-range homing to the bomber's radar transmissions, then at around 4 miles from the bomber, switch over to the SN2 radar system for final approach to visual identification. German POWs expressed surprise RAF bombers kept their radar systems on during the entire mission. The RAF should consider switching the systems off and only on if needed. This would reduce the effectiveness of the Naxos system in tracking the bomber. Once a bomber is visually sighted, the fighter must decide how to attack the bomber by either forward-firing autocannons or up-firing autocannons. This image shows a Bf-110 with the SN2 antenna and nose-mounted autocannon gun ports. This image shows the up-firing jazz music 20mm autocannons mounted on the Bf-110. The muzzle ends can be seen here extending past the fuselage crown. No German Air Force policy exists as to the preferred attack approach, be it front firing or up firing. It depends on the group commander. Seasoned night fighter pilots prefer forward-facing armaments, and this bias will affect the group. More group commanders, though, are being converted to the effectiveness of up-firing cannons given their combat results. German POWs describe a typical up-firing cannon attack in this section. When approaching within 4 miles of the bomber using the fighter's SN2 radar, the Ju-88's pilot and gunner scan the sky visually for the bomber left, right, and up. The radio operator scans aft and glances at the SN2 radar screen. The Me-110's fighter pilot scans up and left, radar operator up and right, and gunner aft. The pilot will define the attack direction from behind or below once radar contact is made. The radar operator vectors a pilot based on his scope return to within 100 meters below and to the aft side quarter of the bomber. This position is in the bomber's blind spot. An off-axis approach is needed to account for the bomber's tail warning sensor and to avoid window if deployed. The distance of 100 meters or closer in height is needed to avoid creating a shadow in the bomber's H-2S radar cone until just prior to attacking it with the fighter's up-firing cannons. When approaching the bomber with the fighter's SN2 radar, the operator focuses on the screen and the pilot speed matches the bomber. The radar operator informs the pilot of the bomber's position and if it changes course or altitude so the pilot can maintain its relative position to the bomber. Once the fighter makes visual contact with the bomber, the Ju-88 radar operator shuts down the radar system and moves to the cockpit to assist the pilot in visually tracking the bomber. The fighter now goes in for the kill. He increases the fighter's speed slightly faster than the bomber and tries to maintain a close position relative to the bomber, like flying in formation. If the bomber dives steeply to the right or left, the bomber is usually lost and a new radar contact will be needed, and the whole tracking process starts over again. Once in firing position, the fighter again speed matches the bomber and aims for the Lancaster's wing tanks. This image shows the vulnerable parts of a bomber and the type of ammo which is most effective. Incendiary cannon fire works best when targeting the bomber's fuel tanks. A POW claimed only a single burst is needed to destroy the bomber. No tracers are used in the ammo belt mix. Attack distance is no further than 100 meters. This is a point-blank attack. Some daring pilots attack close enough to where the bomber's trailing wire antenna is wrapped around the fighter. Like seen in this spot-on, historically accurate drawing. I gotta find some way to amuse myself somehow. The REVI C-12D gun sight is used. This image shows the gun sight, which is harmonized with the autocannons to a distance of 200 meters, but this is irrelevant if firing at a large target from 100 meters. A POW indicated it would be best for a Lancaster to maneuver in a steep dive to the right if under attack. This way, the fighter pilot sitting on the left side of the cockpit will likely lose visual contact and will depend on the observer for relaying the bomber's position. Weaving bombers may be effective if the fighter pilot is inexperienced as it tries to match the maneuvers. An experienced pilot ignores these course changes, slows down a bit, as a bomber will eventually show up in front of the fighter. A bomber should both weave and change in altitude at irregular intervals. A German POW indicated the upfiring cannons are becoming unpopular as the gun system interferes with the plane's master compass. Some captured crews have become lost due to erroneous compass readings. If you have found this Night Fighter Attack Tactics Deep Dive review informative, please consider supporting the channel by commenting, liking, and/or subscribing to World War II U.S. Bombers.